A ball is thrown with an initial velocity of 20 meters per second at an angle of 30 degrees above the horizontal. Calculate the maximum height reached by the ball. So the first thing we do is draw a diagram of what happens. So we see here that the ball has an initial velocity of 20 meters per second. So here's the velocity vector, and it's 20 ms minus 1, and it's thrown at an angle of 30 degrees above the horizontal. So this right here is our angle theta, and it has a value of 30 degrees. Now our next step is to write down what our knowns are. So we have the initial velocity u, which is equal to 20 meters per second. We have our angle theta, which is equal to 30 degrees. And we also have the value for gravity, g, which is 9.8 meters per second. Now, in a previous video, we proved the equation for maximum height of an object undergoing projectile motion. And this is h max, or the maximum height, is equal to the initial velocity in the y direction squared over 2g. Now what we have is just the initial velocity, not in the y direction. So we must resolve the vector component for the y direction. So velocity in y direction, this is simply equal to the initial velocity u. So uy is equal to u by sine theta, and we know that theta is 30 degrees, so we just sub in that value. Therefore we have h max is equal to u squared sine squared theta over 2 by g, which is 9.8. So this is equal to 20 squared by sine squared 30 degrees over 2 by 9.8. So now we have that 20 squared is equal to 400, and we also have that sine 30 is equal to a half. So that means that sine squared of 30 is equal to a quarter. That's 400 by a quarter over 2 by 9.8. And now this is just some simple calculation, and at the end you should get that h max is equal to 5.1 meters, and there's our answer. Thanks for watching.